Alrighty, here we go. We're going to start test 16 review and see hopefully that we can get through this and hopefully answer all your questions because, well, trying to do a lot of hopefullys here. Anyways, here we go. What I'm going to do first is actually show you the answer key for the review, or at least the answers I worked out. I didn't necessarily circle the answers, but you can figure it out from there, right? Okie dokie. So here we go. Alright, so there's page 1. Pause as you need to and then get the answers and then go from there. Okay, so there's picture 2. There you go. So now you got the 2 pictures, and I said pages earlier, but 2 pictures, and you can kind of figure out from there. So pause it if you need to, but I'm going to go through each and every problem as I need to. Okay, so problem number 1, we have 3 to the x minus 4 power equals 3 to the 5x minus 3 power. So you got the same base. Once you have the same base, all you got to do is drop them, get rid of the bases, and set the exponents equal to each other. From there, this is now a typical algebraic equation that you should be able to solve. I like to say again, variables to the left, numbers to the right. So I'm going to subtract the 5x and add the 4. But adding a 4 to a negative number means take away, really. And then after that, all you got to do is divide and you have your answer. So again, if you use that idea, make sure they have the same base. So that chart is going to help, which I did not take a picture of and which I do not have. So hopefully you did take a picture of it because it will be erased by tomorrow. Okay, so problem number 2 says 4 to the 2x plus 15 power equals 32 to the x plus 5. 4 and 32 are not the same, but they're both powers of 2. So I can change the 32 to 2 to the 5th power. I can change the 4 to 2 squared. Then I can put in the exponents, and then all I got to do is distribute as I get rid of the bases. So 2 times 2 is 4, 2 times 15 is 30, 5 times x is 5x, 5 times 5 is 25. And then I'm back to variables to the left, numbers to the right. And after that, all you got to do is divide. Okay, so the main idea here, again, is just trying to get it off into the same situation, try to get them to the same bases. That's the whole point of all these problems, is get them to the same bases. Number 3, what could number 3 say? I don't know. Let's see, there it is. 1 over 27 and 81. Again, so now you need to find a base. Well, they're both off base 3. In other words, 3 to some power can get you the 1 over 27 and the 81. 81 is 3 to the 4th, and 1 over 27 is 3 to the negative 3. This is something that easily you can get off the chart. If you have the chart, it makes this so much easier. And then you just got to, distribute. Once you distribute, you got variables to the left, numbers to the right. You will end up with a fraction. It's possible. Things like that happen as I'm making up numbers. And there you go. The answer there is negative 1 over 17. Notice I keep kind of going through the same steps. Find the same base, distribute, variables to the left, numbers to the right, and divide. So my next one, 25 times 2x to the 2x plus 7 power is greater than 125 to the x. It's in 5, so I figured, it's a 5. 5 squared and 5 cubed. And then again, distribute, and then I just got to say variables to the left, numbers to the right. Notice this way, I still keep it like this, so that way I have the x on the right side. I can divide by 1, but if I divide by 1, it's just still going to give me the same answer of negative 14. Notice how I said minus 3x, and then when I moved the 14 over, there was nothing to join with it, but it's still going to change to a negative 14. So, very simple, fairly easy, nothing too difficult. Alright, 5, 6, 7, and 8, you should know how to do. I mean, it's very easy to go from, say, exponential form to log form. Just remember, it's base, answer, exponent. So, again, base, answer, exponent. So here we go, 7 to the negative third to the 1 over 43, log 7, base. The answer was 1 over 343, 1 over 343 equals the exponent. Base, answer, exponent. Go the other way, log 2, 16, 36. Remember, that's base, answer, exponent. So 216 is the base, the big number. 2/3 is the exponent. and 36 is the answer. Fairly simple, and then you can do the same thing for number 8. And there you go. Alright, 9 and 10, hold a second. Okay, so all you got to do on these is type these into the calculator. Again, all you got to do to do that is press Control and then type in, say, press the 10 to the X button. You should see a log, little blank, little blank. Put these numbers in where they belong, and you press Enter, and you will get your answer. And this one they'll give you 1.5, even though I would still prefer 3/2. But hey, if the calculator gives you a decimal, then write the decimal. I will be okay with that. Actually, no, I won't, but I'll take it. Okay, and the other one gives you -6. So those are, again, fairly easy. All right, number 11. I want to go ahead and say, again, there's 2 ways to do this. And I'm going to show you the long way, kind of what I was teaching, and then tell you about the calculator way, okay? So the long way, and this only works when there's log something equals another number, okay? No log and log, okay? So this has to be only log on one side. So I'm going to say, remember, this is base, answer, exponent. Okay, so I'm going to go, okay, 4 to the 3x power. Notice I'm rewriting it in exponential form. Equals 256. Now, if you type this in, or like, I guess you can figure it out, this is 2 to the 2 squared to the 3x power. You know what, hold up, 1 second. And then 256 is 2 to the 8th. You probably didn't have that in your chart, but if you think about it, okay, 2 to the 7th is 128, multiplied by 2 again, you can find it out to be 256. Remember, they're all going to be off bases of 2 or something like that anyway, or 3 or 5 or 6 or 7. Okay, so then this is 6x equals 8, divide by 6, and you get 8 over 6, which would be, the calculator would tell you is 4/3. So how can you do this a little bit easier on the calculator? Well, you can type log base 4 of 256 in the calculator. When you do that, it will tell you that the answer is I believe it's going to tell you it's 4. Okay, so you're saying 4 is equal to 3x. So you're doing this part right here in the calculator and get that answer, and then all you got to say is, okay, 4 divided by 3 and x is equal to 4/3. So you get the same answer either way. It's just, one's maybe a little bit quicker. How many problems will you have like that where you could do that? I don't know. Well, we'll see. Okay? And we'll see. I honestly, I don't know. Depends on my mood. So here's another one. Okay, so that's a 128. Don't know why I said 129. And, okay, log base 2 of 128 equals x plus 2. So I'm saying 2 to the x plus 2. Oopsie. I hate it when I do that. 2 to the x plus 2 equals 128. 128 is 2 to the 7th. So now I'm saying x plus 2 equals 7. So then subtract, and you got x equals 5. Now again, if you type this in the calculator, log 2 of 128, you'll literally go from this right here to that 7. So you would just be saying x plus 2 equals 7. And then you could easily figure that out from there. Again, it's what you remember how well. Alright, number 13. Now we've got one where there's log on both sides. Okay, when there's log on both sides, it's a quadratic. Notice that's an x squared, so we can drop it and just say x squared is equal to x plus 12. Now, since there's an x squared, everything has to join the x squared. It's just that powerful. Move it over, makes it negative. Now I have x squared minus x minus 12 equals 0. You could factor this and get that answer. But here's another thought. You could also graph this and see where they cross. I'll probably keep it something simple for factoring. Think about it like that. So you'll be able to tell the zeros quite easily. And you really only care about the positive answer. So here I'm getting x equal to 4 and negative 3, but we've been saying that the negatives don't count because the domain has to be positive, so get rid of the x negative 3 and we'll go with 4. And that's it. That's all you got to do. But you could easily found that just from the graph. So think about that. There you go. Thoughts to consider. Here's another version of that. but this time you got to say, get rid of the log 25 and say 7x minus 2 equals 3x plus 9. And again, variables to the left, numbers to the right. Subtract, add, divide, answer, bam. And there you go. So again, most of this should be fairly simple. It's almost like they're disguising simple equations or disguising equations within something else. And here's the reason why we were doing this stuff back in the first 6 weeks, first year, doing it back again in Algebra 1, trying to get y'all ready for these type of things. A lot of the higher mathematics, the better you are with your algebra skills, the lot easier that class will be. Alright, so 15 and 16, I'm putting them together here on the same page. And here's the reason why. It's important when you have a less than or a greater than. When it's greater than, you're just going to say, okay, write the x on the left side. So 4x greater than base exponent, 6 to the third power. 6 to the third power is 216, so then all you'd have to do is figure that out and then divide by 4 and you got your answer. If I had like 4x plus 3, you would have subtracted and then divided and gone from there. If you have a less than, though, you're saying, yes, 7 to the second power like that, but you also got to put it in between 0. 0 and 7 squared. So notice this right here is not between these two because there's a domain again of positives. So from there, we move the 1 over to the other side, so we're going to say plus 1 to both. 7 squared is 49, plus 1 is 50. And then you divide by 2, everything by 2, and you get your final answers. So again, keep in mind that when it's greater than, you want it to be greater than, stay greater than. But if it's less than, it's got to be between 0 and the number. Here's another example. So this is not on the review. Okay, so this is a greater than. So I'm going to say 3x minus 2 greater than 5 squared. So this is where I'm getting that 2 and that 5 to make 5 squared. 5 squared is 25. So now I'm saying 3x minus 2 is greater than 25. Add 2 to both sides. And you've got 3x greater than 27. Ooh, this worked out nicely. I chose some nice numbers. Divide by 3 and x is greater than 9. And you're done. Okay, so very simple. If I had done this with a less than, let's see. Okay, I'm taking the same problem, but now I turn it to a less than. So now I've got 3x minus 2 less than 5 squared, but at the same time I got to say between 0 and 5 squared. So I'm going to add 2 to both sides. So I'm going to get 2 less than 3x less than 27. We already know 5 squared is 25 plus 2 is 27. Divide by 3. And I get 2/3 less than x less than 9. So now it comes between. And that's it. And there you go. So here's a very simple set of examples, and that's pretty much it. Do I want a secret word? I don't know. We had a fire drill today. I gave some extra points for that. But hey, I hope y'all are ready for this test, and I hope y'all have been listening. Sure, why not? I'll give you a secret word. You have to write it above your name, and the secret word will be fire. And there you go. Hope y'all been listening. Hope y'all got a lot out of this, and hopefully y'all will do well. I believe in y'all very much. Y'all take care. Do good.